Today I'll be giving you a brief tutorial on how to use the JUnit framework for Java. We're going to start off by creating a source folder to contain all of our files that we'll be using in this project. Opening up that source folder, where we're going to have our main directory at, we'll create another subfolder in there, our top level package. We'll go ahead and call that com. And then underneath that we'll create another folder for packaging called test. Let's go ahead and open up that test folder. And inside of here, we're going to go ahead and create our first Java source file. We'll do it by creating a new text document. And then we'll name that text document the name of the main class we're going to have in there. In this case, we'll just call it Hello World and give it a Java extension so that the compiler knows that it's a Java source file. To make the editing and everything on here very universal and easy to use, we're going to go ahead and just edit everything in Notepad today. So let's open up that Hello World Java file in Notepad. Let me resize it here so you all can see it. And we'll go ahead and start out the source file by giving a package name. And our package in this case is com.test. Since we're under our main source folder, we have a com folder and then a test folder that we've put this in. We'll declare the name of our one public class for this, and by rule that has to be the same name as the file that we've created it in. So the name of our class is helloworld.java. And then inside of our main class here, we'll go ahead and document saying that we're going to have a class in a method in this class that will just simply print out the words hello world. And we'll go ahead and name that class, or that method, say hello, and give it a string return type. And then we'll go ahead and create the method body. And that method body is just going to return that string saying hello world. And we'll create another class in this, another method inside of this class. And the purpose of this method is just to do a system out print line so we can verify what in fact our class is going to, or what that method does. And we'll just have it do a print line of the output from that first method. And we'll go ahead and save that Java source file. And the next thing we're going to do is go ahead and open up a command prompt. And we're going to use that command prompt. That's where we're going to do all of our compiling from. Now we're going to go ahead and compile our class that we just created a second ago, that Hello World class. We'll go ahead and use the javac command and do a verbose output on the compiler. And we can see, looking through the lines that we've got for the output, that in fact the class was made correctly. So our entire compile did go correct this time. So let's go ahead and switch over to the directory, our main source directory. And then underneath that source directory, we'll go to where our helloworld.java file was created. And we should see there that we have a helloworld.class file. And there's our compiled version that can now be run. We can execute our class. Now we're going to go ahead and create the test class that we're going to use to test the Hello World class that we've just finished creating. And we'll go ahead and call that class Hello World Test.java. Let's go ahead and open up that file also in Notepad here. Since we're again starting from the same folder under our root source directory, this is again the package com.test. And we're going to declare our class here, and the class name is Hello World Test. And it's important to note that this class is actually going to be extending the base JUnit class called test case. So in order to allow us to extend that test case class, what we're going to need to do is we're going to need to import the base class from the JUnit framework. I've already downloaded the zip file included with that, which you should be able to find very easily, but once you've downloaded the binaries for JUnit, we'll just extract them into our main source directory, and we'll include it into our class path when we go ahead and compile. Let's go ahead and comment our class here and state that this is the class that's going to be testing our Hello World class that we created. Okay. Now we're going to go in here and let's go ahead and create a constructor for our Hello World test class. And the standard constructor for the test case class from JUnit includes a string with it, so we're going to allow a string input for our constructor for our extending class. And for our constructor, we'll just use the base constructor from JUnit and pass it in the same variable that we're giving it. Now, the input variable that we look for, that JUnit expects, is the name of the class that it's looking to test. So in this case, the test class is actually the class that we're in, hello world test.class. Now we need another method in our class here, so that we have a main entry point that when we run it from the compiler. So it's a standard main method right here, and our main is just going to say to go ahead and construct this class so that we can run the test. We're also going to be using the JUnit Swing UI test runner class. We'll go back and import that in a little bit. And then we have another method in here called test say hello. Now, by convention, any test that you create inside of the JUnit framework should start with the word test as the first 4 letters of the name of the method that's in there if it's a test that you're actually expecting to run. Inside of our test class, we're going to go ahead and create a hello world object, and then we're going to use the JUnit command assert equals. Assert equals takes 2 inputs of the same data type, and the first input is going to be the expected return value, and the second part of the second input to the method is going to be the actual return value. So in our case, it's the say hello method's output. Again, since we're using the JUnit.swingUI.testRunner class, so we can actually visibly see the effects of running our JUnit test, we'll go ahead and import that package, which is JUnit.framework.testRunner. And also, when we use the assert equals method down below, it's possible that we're going to have an assertion failed exception occur. So we also want to go ahead and import that assertion failed exception. Even though we're not explicitly catching it in this situation, we should go ahead and import that class just in case we do want to catch that exception at a later time. So go ahead and import that, save our test case here, and then we'll go ahead and back and compile our test class and see what the output of running it is. I've just gone ahead and extracted here from our JUnit source zip the JUnit 381 package. The JUnit jar file exists right underneath that. So let's go ahead and open up our command prompt and we can get started with the compile here. Alright, now we're ready to begin the compile. As you can see with the compiler command, we've included the verbose option so we can see all the output that's going to occur from this. In the class path variable, we've included the JUnit jar file and also our main source directory. And on the last line here, we can see that the output is the hello world test.class file. If we actually go into our main source directory down to the com.test level, we can see that that class file is now there. So the next step is to go ahead and run our test. We'll switch out from the main directory of our Java compiler, and now going to the Z drive, we'll go to our main source directory. In our source directory, we're going to issue the Java command, and we're going to add in the class path variable so that we can again access the JUnit test framework. So we include from our source directory the JUnit 381 jar, and we're also, after that, going to follow by a semicolon and then include our main source directory so that we also have access to the Hello World class that we made earlier. And then the last part is the actual class that we're going to execute, Hello World Test. And once we hit run here, we should see the JUnit test swing UI come up. And we can see that we actually had a failure here in our first test, but we can at least see what the framework looks like, and we get a nice description of what went wrong. That our Hello World Test class was actually not declared public, so the JUnit test framework wasn't able to access it. You can see from our test hierarchy that we only had one test listed under the test Hello World class. But we get a good idea of what the look and feel of this is like now. So let's go back into our Hello World Test class. Open that back up in Notepad. And we can see we indeed forget to declare that class as public. So now all we need to do is edit this class to be publicly accessible, and then we'll go ahead and run the compile again. I've gone ahead and corrected that error, and our compile has gone successfully for our Hello World Test class again. We can see in the last line that the Hello World Test class file was generated. So now let's go ahead and execute that Java command to run our Hello World test. And voila, our test has passed this time. If we were to click on the test hierarchy tab right now, we'd see that we had only one test, but that test did pass. Each time we click the run button, our entire test does in fact execute. But let's go ahead and exit and get on to the next section. We're back in our Hello World class now, and we'll go ahead and add a new method in here that we can test. We'll have this method be called getSquare. It'll return an integer and takes an integer as input, just simply returns the square value of the input that was given to the test class. So we'll just quickly define it right here. And in the interest of saving time, I'll just add a few comments here for us and finish off the definition of this class. Now let's add one more class. This will have a float return type, and we're going to call this class divide. We'll give it two floats as input, anum and bnum, and the output of this class is simply going to be the quotient of anum divided by bnum. So we can do a few more interesting things there and hopefully break our test a little bit better. And now that we've got both of those new methods declared and defined, we'll go ahead and compile our Hello World class, and we've got a successful compile. Now let's go back over to our test class. Back over here in our test Hello World class, we're going to go ahead and add two new methods, one for each of the methods we just added to our Hello World class. We'll go ahead and call the first one test squaring, and we'll go ahead and run through a couple of tests in it. First thing we need to do for each of our test classes is going to be to declare a new instance of our Hello World class. And then once we've done that, we'll be able to execute the methods that we've just added in. We should give at least one test method for each substantial method that we have in our main class that we're looking to test. So here we've added one for each. And now that we've declared our main object, let's go ahead and try and square the value 3. We're expecting 9 as the result for that. So we should usually have 9 as the first input since it's our expected result, and then we'd use the getSquaring methods, the getSquare method with 3 as the input for our actual result. Here we'll just do it backwards because it really doesn't make a functional difference, but we should usually do it with the expected result first. Then let's try a test that we know should fail. We'll go ahead and use the getSquare method with 4 and use 15 as a result, whereas our result should be 15 or 16. So we should see a failure come up when we run JUnit for that one. And then back here in our test divide class, we'll also add a new instance of Hello World. And then we'll try 3 different examples here in testing out our divide method. First we'll try dividing 9 by 3, expecting 3 as a result. Shouldn't be any shocker there, and we should get it exactly what we expect. Next we'll try something a little bit more difficult. We'll try dividing 4 by 0. Divide by 0, in this instance, using floats, since we'll end up using the round method actually, should give us a very bizarre number quite outside of our expected range, so something we should actually be testing for. And then, as a last test, how about we'll go ahead and try dividing 0 by some random number. We'll go ahead and use the number 4 for example in this case, but anything should work as we were expecting 0 for the result. I've taken the liberty here of finishing up our test class, getting the methods finalized, so let's go ahead and compile our test class and actually execute our JUnit. We can see that we have the regular test class coming out compiling fine, so let's go ahead and give that Java execute command to our Hello World test class, and we can see we've got a few failures coming up this time now. So running through our class, we know that we have some situations that we should be handling at this time which we're not, so let's go ahead and get back to our test class so we can improve our base class. So now we know what to look for. So now that we know that we need to check for dividing by 0, go back into our Hello World class and do a conditional check to see if we are in fact dividing by 0. So we'll check to see if the bnum is equal to 0. If it is, then we'll go ahead and throw an exception describing that you cannot divide by 0. Now in this case, the original code here is somewhat distorted because you should actually be rounding 0 off to a significant number of digits, so maybe if bnum divided by 100,000 is equal to 0, that might be a more accurate case here, as your float being equal to 0 is not going to happen very frequently. Also, this test we now need to declare the divide method to actually throw exception, but once we got that, we're all set to go and rerun our test case. So we'll just finish up that here. Now after recompiling our test class, we'll go ahead and run JUnit again, or run our class rather, and have JUnit execute. And we can see that now that this time we had 1 test pass, we had 1 error, and 1 failure. So let's go into our hierarchy here, and we can see that the test say hello passed. The test get squaring didn't have any fatal exceptions occur in it, but it did have an unexpected result, and in our last test testified we had an error occur. It's from that divide by 0 exception that we're now throwing. So back in our test case, we'll go ahead and wrap the line that threw the exception into a try-catch clause, since we're expecting that exception to occur, and we should actually always be testing for expected exceptions. If we were doing this for a live production application, we'd probably want to extend that generic exception to be something more explicit. In this case, it would just catch anything going wrong with it, and we might not be catching everything that we need, or rather we'd be catching more than what we'd expect. And then we'll add in another clause, and this clause is fail. We want fail to occur when we reach a point in the test code that shouldn't actually occur. So we'll just add that in here since we expect to have that exception occur. And while we're at it, let's go ahead and clean up the rest of our test class. We'll correct the unexpected result up in test get squaring, and we'll move the expected results to the beginning as we're supposed to with this test class. Then we'll go head back and run through it again and see what our results are. So now let's transition over, and we'll go ahead and compile our test class, see what the results are. And we have a failure in here that we're not catching an exception. Back in our test class, even though we are handling the exception case where we're expecting divide to throw an exception, we're not handling the other ones explicitly, so we have to declare that the method may actually throw the exception. So go back and add that in, that the test for divide may throw an exception, and we're compiling properly now. So now we run JUnit, and we see that all 3 of our tests have passed. And now we know that we have some solid code that can actually perform properly, and we don't have to worry about it again in the future.